Hello, everyone. Many people think that landing a rocket is relatively simple process because we usually think that getting the rocket into the skies is the more important thing. But also, how to solve the problem of spacecraft return is also an essential part of this process, just like the textbook introduction. When landing, the very large delta V of the spacecraft now needs to be brought back down to zero, preferably to get gentle stop. A lander is a spacecraft which descends towards the and comes to rest on the surface of an astronomical body. So, let's discuss two scenarios. The first one, the case of landing on the Earth's surface. Landing on bodies that have an atmosphere. When a spacecraft is targeted to land on a body which has an atmosphere, it must first enter into the atmosphere at a high speed. In the case of a spacecraft that is returning on Earth, this phase is called re-entry. The altitude at which the atmosphere causes drag relevant for entry is called the entry interface. For Earth, the entry interface occurs near Kármán line, while Venus is at 250 km and Mars is at about 80 km. Next is the second, the case of landing on a non-Earth surface. I found a related video about Apollo moon landing video that might be helpful for this proposition. For an airless body, the landing vehicle must provide the full delta V necessary to land safely on the surface. A powered descent with a gravity turn is the best option. The Apollo lunar module used a slightly modified gravity turn to land from lunar orbit. This was essentially a launch in reverse, except that a landing spacecraft is lightest at the surface while a spacecraft being launched is heaviest at the surface.